Let us learn another rule about differentiation. Which one do you think is next? We did the rules for constant multiples, for sum and differences, power rule, product rule, quotient rule, and they were all very easy. Now the chain rule, which we do today, is also easy. It is a rule for the differentiation of composite functions. Remember composite functions? So these are functions of the form f of x is equal to f of g of x. So you take one function and sub it into the other function. Sometimes you call it the inner function g and the outer function f. To differentiate this, we have capital F prime equals little f prime evaluated at g of x times g prime of x. So in words you can formulate it like this. We differentiate the outer function first, evaluate it at the inner function, and then multiply by the derivative of the inner function. Now there is an alternative notation using the Leibniz notation, where you do these dy by dx and du by dx kind of thingy. So in that notation, you write y equals f of u, and u equals g of x. So you see this kind of implies that you substitute u into f right here. So it's a composite function, and then dy by dx equals dy by du times du by dx. So this would be the outer derivative here, and then this would be the derivative of the inner function right here. So let's do examples. I personally like the f prime notation better, so that's what I'm gonna stick to, but some people really prefer the Leibniz notation, and then you can use that too. In the first example, we have f of x is square root of 1 plus x to the 4. So you can see the outer function is the square root, okay, and the inner function is 1 plus x to the 4. And then let's apply the chain rule right here. So f prime of x, that would be little f prime. Now we need the derivative of the square root. And then we can use a power rule, so it is u to the 1/2. If I differentiate, I get 1/2 times u to the minus 1/2. So this is 1 divided by 2 root. Okay? But now we are not subbing u, we are subbing the function g of x, which is 1 plus x to the 4. And then we multiply the derivative of the inner function. So let's maybe write this down, d by dx, 1 plus x to the 4. And so then this is 1 divided by 2 root 1 plus x to the 4. And then differentiate the function g. Derivative of 1 is 0, and derivative of x to the 4 is 4x to the 3, power rule. So then maybe write it a bit nicer here. Then we write this as 2x to the 3 divided by root 1 plus x to the 4. So that is the derivative of this composite function. Let's do another example, which is f of x equals sine of x squared. So then here the outside function f of u would be the sine function, and the inner function g of x equals x squared. Okay, and then we can do the chain rule again. F prime at x is derivative of the outer function. Derivative of sine is cosine, but now evaluate at the inner function, so it would be cosine of x squared multiplied with the derivative of the inner function, 2x. So then write it nicer, 2x cos x squared. And then to be very clear, cos x squared means cos of x square in brackets. So you take the cosine of x squared. Now let's do a similar example down here, sine square x. And I want to make the point that sine square x is not the same as sine x squared. So it really matters where you put the square. So here we have f of u is u squared. Now the outside function is a square function. G of x is the inner function, which is sine x. So this here really is sine of x and then all that squared. Okay, so then chain rule f prime of x, derivative of x squared is 2 evaluated at the inner function, which is sine x, times derivative of the inner function, which is cos. So it is this. And then you see here, these are not the same. Of course, they are not the same functions either. So I think with a little bit of practice, this rule is actually rather easy. Let me summarize. So here I remind you of the previous rules, the constant multiple rule, rule for sums and differences, power rule, product rule, f prime g plus fg prime, quotient rule, which is gf prime minus fg prime divided by g square. Yeah, and then the chain rule, which is f after g, all prime, is f prime evaluated at g times g prime. So that would be a very short and sexy notation for the chain rule. Oh, hey Marlo. Marlo, what do you have for me? You made me a chain sculpture? Wow, now I'm curious. Let's have a look. Well, yeah, kind of.